Hello, my name is Cary Jensen, and welcome to CodeRage 7. This session is LiveBindings, Expressions and Side Effects. I offered to present this presentation because there are some elements of LiveBindings that I think are terribly important, but aren't as obvious as they were if you worked with LiveBindings in Rad Studio XE2. LiveBindings in Rad Studio XE3 have been improved significantly, and it's a very, very exciting improvement. In Delphi XE3 and C++ Builder XE3, you have visual LiveBindings. And visual LiveBindings allow you to very conveniently and very easily wire up properties of objects both in your user interface and other classes that you want to have synchronized with each other. One drawback of visual LiveBindings is it removes you, as a developer, it removes you one layer from the actual workings of LiveBindings. And LiveBindings are really quite exciting and have some very big strengths, and some of those are not exposed through the visual LiveBindings interface. So what I wanted to do is, rather than cover material that a number of other speakers here at CodeRage 7 are going to cover, the visual LiveBindings, all those new flashy features, I want to take a step back and consider the underpinnings, the inner workings of LiveBindings, talk about what you can still do with LiveBindings that are not as obvious when you're using visual LiveBindings, talk about expressions and the power that they have, and put a particular emphasis on LiveBinding expressions and side effects. So I'm going to begin this talk today by giving a definition of LiveBindings. I'll talk further about LiveBindings and expressions. We're going to see that at the core of LiveBindings is this really remarkable scripting engine called the expression engine. And I'm going to talk about what the expression uses and how it performs its operations. And we'll look at a variety of different expressions. I also want to remind everyone how to create LiveBindings manually in Rad Studio XE3, because, like I said, it's not as obvious that this is even a possibility, because visual LiveBindings and the LiveBindings designer is so powerful that that menu items that you used to have when working with LiveBindings are now gone, and I want to show you how to get back to those in case you want to use some of those features. And of course, the features I'm talking about is the capability of having LiveBindings that produce side effects. And then we'll look at we'll look at a couple side effects. Then I'm also going to talk a little bit about chaining of method invocation through LiveBinding expression evaluation. And I want to make a few comments about instance methods versus class methods and how they work into the evaluation in the expression engine. So that's basically, we're going to look at LiveBindings from quite a different viewpoint than many of the other talks you're going to find here at CodeRage. So let's begin with a general definition of LiveBindings. LiveBindings is a mechanism in Rad Studio for associating the property of an object with a string expression. The expression, which is evaluated at runtime, can be a property of the same object, a property of a second object, or a complex expression that includes properties of objects, literals, operators, and methods. LiveBindings are objects that contain one or more expressions. In fact, it's not uncommon to find some LiveBindings, especially with sophisticated controls such as a DB grid or the string grid, that have a dozen expressions or more. Expressions consist of a string that are evaluated, or expressions are strings, okay, and they are evaluated by the expression engine. In practice, the LiveBinding invokes the expression engine to evaluate the expressions. In some types of LiveBindings, you have to notify the LiveBinding that it should request that the expression engine evaluates the expressions, but it is the LiveBinding that talks to the expression engine and gets the expression engine to perform a runtime evaluation of that string and producing a value as a result. It is possible to invoke the expression engine directly. And that's what I'm going to demonstrate in just a moment. However, I want to make a comment about that, because while you can, just because you can do something doesn't mean you should do it. And there may be some situations in which you find it valuable to use the expression engine directly, but in most cases you're really going to be defining expressions for live bindings and let the live binding call out to the expression engine. I think you'll see once I start demonstrating this why that's the case. In fact, calling to the expression engine directly is definitely far more complicated and involved than using a live binding to perform the same task. And that is the reason why the expression engine is something you're probably not going to code to directly. Now, the elements of the expression are all, the expression itself is a string, but it can contain a number of elements. It can contain literals. Now, these literals may look to us when we inspect them to be either string literals, they could be date, time literals, they could be numeric literals, and so forth. We have operators too, so addition, concatenation, multiplication, a variety of different operators, Boolean operators and so forth that we can use to perform operations on these various elements of the expression. We can also use custom methods, and Rad Studio comes with a number of custom methods that are registered for the expression engine use. And if you wanted to, you could create your own custom methods, but that is really unnecessary. And you'll see when I start talking about side effects and live bindings, you'll see that it's actually very easy to create an object whose methods you can invoke, but there's nothing trivial about creating a custom method and registering it through the OpenTools API to make it available to the expression engine. So while it is a possibility, it's not something that most developers are going to want to do. We can also use within our expression properties of objects that are within scope of the expression engine. And scope here is a very, very important concept. It basically is those objects that you've informed the expression engine about their existence. So by default, a live binding is going to inform the expression engine about the objects in the control property and the source property, the control component and the source component. If you are using the expression engine directly and you want to use properties of objects or methods of objects, you're going to have to inform the expression engine of the existence of those objects, and you do that by placing those objects within scope of the expression engine. So in general, you can't just use anything that is available to you. You must use, you've got literals, operators, custom methods, properties of objects and scopes, and methods of objects and scope. So let's get to the demonstration. So here we go. And now I want to acknowledge that the original source code that this example is based on was originally written by Jim Tierney, who's giving at least one, if not more, presentations at this CodeRage 7. So I want to acknowledge his work. I simplified it a little bit in a couple places, but he's the one who wrote this original application. So with that acknowledgement in place, let me go ahead and run it, and let's start talking about some of the elements. Before I click on the first button, just a simple expression, let's look at the code behind this. Okay. What we have is we begin by creating a scope, and in this case it's an empty scope, and we use that by calling the tDictionary scope objects create method, and that returns to us an iScope reference, which is an interface that has some basic scoping capabilities. Next, we use the tBindings class to create an expression using that scope, in this case an empty scope, and a string. In this case, I'm using edit1.text, so I'm using the text property of the edit control where I'm going to enter in my expression, and that's going to return a tBinding expression, which I then evaluate using the expression engine. After that, we can get the value of the expression. This is a t value, and based on the values of the t value using RTTI here, we either can evaluate that the expression is an empty expression, or if we determine it's an object, will display the class name of the object. Otherwise, we'll use the toString method of the expression to return the value in a string format that we then are going to assign to a simple T label that appears on the form. So if we go back to the form here, here's where we're going to enter the expression. This is the T label in which the result is going to be displayed. So let's go ahead and try something simple. Let's just do some simple math, 1 plus 4. And I'll click this button, and the result here is 5. We can also do strings. Now, strings are interesting because since the expression engine is a different beast than the actual Delphi compiler, in this case I'm using Delphi, we can define expressions using either single quotes or double quotes. So I could create an expression here. I could say 5 plus 5, and I use single quotes in the first instance and double quotes in the second instance, and click this, and I get a concatenation of those values. Now, the expression engine can do some evaluation and conversion of data, but there are some things that it's not going to understand how to do. For instance, it doesn't know how to add 5, and this thing that it is actually it's not really sure what values those are. So now, fortunately, there are custom methods that can perform transformations if we need those transformations to be performed, and those are the custom built-in methods. Let's go back to our code here and look at how we add the ability to use custom methods. Now, I'll mention right now is that if I use the toString custom method function, but I use the simple expression button, this is going to fail. And the reason why is that the custom methods are not by default in scope of the expression engine, at least in the context we have here. So this is how we're going to add the custom methods to the scope. We create our empty scope, and then we create a nested scope into which we place the custom methods. And we do that by calling tBinding methods factory, get method scope, and that creates a nested scope. So now within our scope we have both we have an empty scope, plus we have in there also the scope that represents the or provides the expression engine with reference to these methods. So let's go ahead and click this button, and it has here concatenated the string 5 and the numeral 1, but as a string, and it has combined that together. So right now we see 3 base elements of the string expression that the expression engine can work with. We see literals, and we see operators, and we see custom methods. But where things get really, really powerful is when you start placing objects within scope of the expression engine. And we can see that here in this event handler. This is an expression with an unnamed object. Now, what we're going to do here is instead of creating an empty scope, we're starting by calling the wrap object method, passing to it, in this case, an object, which is our tEdit that we're using to enter our data. And that creates a scope, and then we're adding the custom methods into that scope as well. And now when we create and evaluate our expression, we can use methods and properties of that edit1 object, that tEdit, in our expressions. So let's come back here. And let's try something. Let's just do something very simple. Let's say self.top. And that shows a value, self.left. Now, self in this case is quite a bit different than the self that Delphi developers encounter within methods, instance methods of a class. Specifically, it's referring to the unnamed object in this case, it's not referring to the instance of the object whose method is being executed, because we're not doing that here. We have no method that's being executed on an instance of an object. The interesting thing about unnamed objects in scope is that we can reference their properties. Actually, let me put something else here. Height. We can reference properties and methods of those objects without that self-qualifier. So if you have an unqualified reference and there is a single object in scope, it's simply going to go out and look at the properties and methods of that object. Now, when you refer to properties, you refer to them by name, and this could include something like, for instance, the name property of that object. But if we want to execute a method of that object, we have to take an additional step. For instance, or specifically what I mean is that if you want to execute methods of objects within scope, you must include the parentheses. And what's really cool is that we're not limited to just one level of method invocation or one method of reference. Here, I'm going to refer to the self.owner.class name. And what we see is the owner property is pointing to the form, and class name is now being executed on the form. Let's try another method, unit name. And the owner's unit name is mainFormU, and that is in fact the unit of where the owner is defined. It's also possible to work with named objects, and here's an example of that. In this case, we're creating an empty scope, but we're mapping a wrapped object to a specific name, and this is not as common, especially if you're using the expression engine directly, because it does impose some specific limitations. For instance, if I click this expression with named object now, we're going to get a problem. It doesn't know what self is because we're not working with an unnamed object. What we have to do is actually provide the name myEdit. That's the name we provided right there. We have to provide the name, and in all cases, let's say it's edit.text, myEdit.text, and class name with parentheses, and that's how you work with a named object. So there's an introduction to the expression engine, and just to give you a sense of what you can do with the expression engine, but more importantly, what expressions can contain and the kind of references they can have. Now, the reason why this is so important is that, as I mentioned, in visual LiveBindings, some of this is not really as approachable in terms of creating customized expressions. So, for instance, let me place an edit and a button here, and this is kind of a classic little demo that you've probably seen a million times about visual LiveBindings. I'm going to bind the text property of the edit to the caption itself, and this is sweet. Now, when we created that visual LiveBinding, we got a binding list in there, and let's just run it and see it operate. And here I can. So we've got that going for us, and it's linked up. And if we look at the LiveBindings editor, we'll see that there is a link control to property binding here, and if we double click it, we'll see that there's a number of expressions here. If we look at all the expressions, there's 3 different expressions. But notice that down here, where you would normally edit an expression if you were working in Red Studio XE2, it's not editable. So this is kind of an important thing. If we can do all sorts of really clever things with the expression engine, but we can't edit these visual LiveBindings expressions, then that poses a kind of an interesting problem for us. So what I want to do now is talk about how do we get back to being able to actually make our own custom expressions with LiveBindings. And so let's go ahead here and let's put away the LiveBinding designer, and let's take and remove this LiveBinding that was created for us, and let's create this is a simple bind expression LiveBinding, and we'll set the control component to be the button. That's the one that's going to be affected in this case because we're source to control. That's going to be the one affected by the expression, and the edit is the control of interest, and we'll come down and say the button's caption is going to be affected by the text property of the edit. Now, there is one thing that we want to do while this works. This will work when the LiveBinding expression is going to be evaluated and applied when this becomes activated. But if we want to be able to have these LiveBindings stay updated, in this case, because these are manual LiveBindings, we're going to have to take and use the notify method of the bindings list in order to keep things synchronized. So now I'm going to run this, and This is actually even more responsive than we saw in that last example, that because of the way the live binding is executed. But more importantly, the point is here that it is possible using the bindings editor to get to the individual bindings and to create your own custom bindings, and then to go in and actually manually create your own binding expressions. So that is, let's face it, that is more complex, more steps and so forth than using the visual live bindings. But what do we get from that? Well, here we get to expressions and side effects, which I think is one of the more exciting elements of the expression engine, if not live bindings in general. Don't get me wrong, the visual live bindings is so great. I mean, it is, you can easily put together your user interface with minimal code. That means less code to maintain, and have really nice interaction between your objects, all defined declaratively. However, when we manually create our expressions, we can perform side effects. Now, what is a side effect? A side effect is an additional operation performed as the result of the execution of a method. Normally, in the object-oriented world, we think of side effects with respect to property accessor methods. So, for instance, if we have a property called enabled, we might have its write access be controlled by a method which we would call a write accessor method, and that means it's a method that gets executed in order to set the enabled property. A side effect would be something else that happens, not just storing the fact and performing an enabling or disabling of something, but actually performing some other operation. For instance, if you have a component that's dependent on yet another component, when your primary component is disabled, it may need to somehow inform or control that other component, and that would be a side effect. Well, you recall that we can execute methods of objects in scope, and you know what? Those methods could perform side effects. And so what I want to do is show you a couple examples, primarily one example that I think kind of demonstrates this rather nicely. And this is found in my example over here called the currency converter. So I set up this project like the one I just had, except instead of having an edit and a button, I have two edits. And let me show you how this performs, and then we'll go and examine what is actually going on here. But this is a currency converter where I can type in the number of dollars I'm interested in, or I can type in the number of euros I'm interested in. And what it does is it calculates the equivalent. So dollars converted to euros, euros converted to dollars, and that all happens actively as we type, as long as it makes sense to get those values. So how is this happening? Well, what we have here is a live binding that has, in this case, this is a bind expression items, and it has two expressions. One expression, if we look over here, one expression that is source to control, and the other that is control to source. The most important thing about this is that my expression is actually reaching out to this unnamed components, which is the dollars edit, in this case an edit, and it's reaching out to its owner. And the owner has some object called converter, and the converter has a method called convert to euros, and I pass in the text of that dollars edit and assign the resulting value to the text property of the euros edit. And the same thing is happening over here, where the euros edit, when it's being modified, it calls out to the converters convert to dollars, passing the euros edits text property and assigning the resulting value to text. So where does that magic occur? Well, here's the main form. And you'll notice that in our main form class, we have a public object of type tConverter. And in the creator, or the onCreate event handlers of this form, we call the constructor of the converter and assign it to this property. This main form is owner. It's what the owner property of that tEdit points to. As for the converter itself, this is a class that has some properties, euro conversion, dollar conversion, also has some functions, convert to dollars and convert to euros. Now I have to admit, I've cheated a bit here. I put in a constant value, and really in the real world, we would somehow obtain this this conversion coefficient in real time. So we would probably get it from a web service or through some other dynamic mechanism. Nonetheless, it's performing these conversions. So let's go back and look at that again, exactly how this is all working. We do have a call to notify on the event handler. And if you notice, that's all the code on the form. That's all there is. It's actually through the live binding expressions that we're getting this execution of the convert to dollars and convert to euros method of this object. And it's not even the owner. It's not the t-edit that has convert to dollars, and it's not even the owner that has to convert to dollars. The owner has an object that it can call to. And I want to stress this because it is a very, very important point. These are strings. They are in fact being evaluated at runtime, and they could be dynamically modified at runtime. Imagine if for whatever reason we wanted to reach out to a RESTful web service and retrieve a string and then assign it to one of these expressions. It would be possible for us to have a remote service actually defining what will be evaluated and executed at runtime within your application, which, while you could say that sounds scary, on the other hand, that's terribly exciting as well. It gives you a level of flexibility that's just not achievable in the compile time world of the compilers that Delphi and C++ Builder are employing. I have one final example that I want to show you that I find very interesting. I played around with this quite a bit. You know, one of my questions was how far can we go as far as reaching out? You saw me reach not only from the t-edit to owner, but to owner to converter. And this example shows you can extend that as far as you want. Within this main form here, I've got some for declarations of 3 different classes. My main form has a constructor that and a reference to my class A. And if you look at my constructor, I call the constructor of my class A. Now, going to my class A has a constructor and a reference to T my class B, and of course it creates an instance of T my class B. My class C is a field of my class A. Here we go, and we have a constructor there as well. And then I stuck on T my class C, I have both an instance method and a class method. Class methods, importantly, can be invoked not only on the class itself, but a reference to the class, but you don't need an instance of the class. In other words, I could have a variable of my class C and invoke the function a class method here, and it will work because it doesn't require an instance of the class. An instance method, however, does require that it be invoked on a constructed instance of the class, or you'll get an access violation. So what I'm doing in the instance method is I'm just returning a string that says this string is returned by an instance method, and then my class method of my T my class C, this string is returned by a class method. Now, if we look at my bindings list and my expressions here, I have one expression that actually reaches out and assigns to owner of label 1, or the caption of label 1, the value owner, my class A, my class B, my class C, a method A. And the other expression, likewise, reaches out and it executes a class method on that object. Just in case you were curious if class methods could be invoked, of course, class name that I demonstrated earlier in the demonstration of the expression engine is in fact a class method, so you might have concluded that already. Now here's the interesting thing. I'll run this, and when it starts up, okay, this string is returned by an instance method, this string is returned by a class method. Now there is something that I didn't tell you about, and that is that if we look at this particular live binding here, its auto activate property is false. Okay, so this bind expression, its auto-activate is false, and this bind expression, its auto-activate is true. You'll also see when we look at the code that in the constructor of the form, not only do I create an instance of T my class A, but I call this method activate bind expression label 11, which simply sets the bind expression active property to true. So let's go ahead and run this and see what happens. That's predictable. The form was created. We activated a non-active expression, and what we got was the string from the class method, and we got the string from the instance method evaluated. Let's go make a slight change to this. What happens if we remove that call? So we have a live binding that is not auto-activated. The form gets created, and we don't get the evaluation of the instance method until we click on this button here. One last example I want to show. We'll leave the call to activate the live binding. We'll leave that commented out, but we'll go back to the live binding and we'll change its auto active property and auto activate. We change that to true. This, I think, is probably one of the more surprising results. Now, this is different than each of the two previous examples I showed you. In the first example, we activated the live binding after the form was created, and we got the string from the instance method. When we remove the call to activate the live binding after as part of the form creation, we could click on this button here to activate the live binding, but before we did that, we saw the caption label 1 in the T label. In this example, the live binding is auto-activated, and it's actually activated now. If I click this button, nothing happens because the expression is already active. And notice, we don't even see label 1. The caption's gone because the expression engine evaluated the expression, and the expression evaluated to null and returned an empty string. And the reason why it evaluated to null is that the instance of my class C didn't exist when that call was made. That's how early in the process an activated live binding evaluates its expression. And I think that's just terribly interesting. And I encourage you to download this example and kind of look at what was going on there, because again, the whole point of this talk is if we better understand what the expression engine is doing and when it does it, we can control live bindings better and then make them work for us and do things that otherwise we wouldn't even be able to do in Delphi. Well, thank you for spending time with me during this session. For the code samples and slides I presented here, please visit www.jensendatasystems.com/CodeRage7. There you'll find links for all of my talks here at CodeRage 7. I also want to invite you to visit DelphiDeveloperDays.com. This is a site where you'll learn more about the annual Spring Delphi Developer Days tour, 2 intense days of Delphi training with joint sessions. If you are interested in learning more about my latest book, Delphi in-Depth Client Datasets, you can find links for buying the book and some additional information like the table of contents and other information at jensendatasystems.com/CDS-book. Also, if you need to get in touch with me, if you have questions or want to follow up on something, please send email to cjensen@jensendatasystems.com. I do ask you to put an informative subject line, something like CodeRage 7 or Delphi or LiveBindings or client datasets or something that'll catch my eye. This email address gets a lot of spam, so I look through it, and if you send me an email and you don't hear back for a number of days, go ahead and send me another one. I'm not avoiding you, I just may have missed it. But if you send something with a subject line that says hello or Viagra or something like that, I will not see that email. You can visit jensendatasystems.com to learn more about my company and our services. We do custom development. We do Delphi training. We also do consulting, and other services as well, including system help systems and documentation. If you'd like to follow my blog, you can find that at caryjensen.blogspot.com, and my Twitter feed is found at twitter.com/Cary Jensen. Again, thank you very much for your time, and I look forward to the upcoming questions and answers.
The first one was Karsten asked, is it possible to use more than one scope out of several units with objects? Well, I'm not sure the context there.
One scope out of several
units with objects.
See here.
I mean, in LiveBindings, you can, whatever's used in your unit, you have access to, right? So.
Yeah, I'm not really sure.
Maybe, Karsten, you can ask it in another way. I mean, anything that, since LiveBindings is done at the, or Visual LiveBindings, for example, LiveBindings Designer is done at the form level, anything that your form uses, you have access to. I'm not sure of the context of scope there, Karsten.
Yeah, scope means a number of different things depending on what context. If you're talking about the expression engine, scope is very, very specific. So I suspect that anything that is within scope, well, I really don't know. You know, we're accustomed to scope in the Pascal language, the objects that are within scope of the particular code that's executing in a particular location. I'm not sure really what the answer is. Now, I do see that there is one question. Someone has said that the CodeRage 7 link does not work for them, and I am very embarrassed to say that it doesn't work for anybody, because I intended to be putting that up during this talk, but there was something else pressing. I will have that up there in the next half hour. So that is the correct link, and it'll be a link to both of my CodeRage downloads. I need to finish that.
Okay, let's see. Let's see how many we can get. I've got 4 now, people who are posting about the link. Look, be patient, people. He's in Germany. Uh-oh, now the Germans are going to come after me.
I'm very sorry. This is something I totally intended to do this. And I had something else that I was trying to that I needed to get up. We have a special announcement that we're making, and I needed to blog about that. And I totally dropped the ball when it came to getting this code up there. So it'll be up there shortly.
Everybody will be very patient, I know. And let's see how many more people post about the link. How can I make a bidirectional binding between a track bar and an edit? Of course, Ahmed, you didn't say in a VCL and or FireMonkey application, but okay.
Yeah, well, I've certainly done something like that, a track bar and an edit. Now, whether you could do it in Visual LiveBindings or not, I haven't tried that. I've noticed in Visual LiveBindings some things don't want to behave right, or there are some links that it just denies. But if you listen to my LiveBindings talk from the LiveBindings white papers, you would see how you could achieve something like that. Even if you can't make a direct bidirectional link between the edit and the track bar, you could create a method that is within scope, for instance, a method on your form, and use that method call to perform the necessary validation to make sure that what you add into the edit is a value that makes sense with respect to the track bar. And then also you would do this with a bind expression items, by the way, and you would create 2 separate expressions, one for going one direction and one for going the other direction. So actually creating one bidirectional expression wouldn't be the way to go, but rather use a possibly a bind expression item to and have 2 separate unidirectional expressions.
Yeah, Alf is asking about the whole issue of side effects and what side effects, not only in code, but in a live binding expression or methods it calls, what that might do to expose vulnerabilities.
Well, if you're talking about security vulnerabilities, that's your responsibility as the developer, not to expose your the expression engine to possible injection of strings that you don't want to evaluate. That's very important. Now, the possibility that somebody is going to understand what classes are within scope of the expression engine and then to exploit that, that's pretty low. Nonetheless, you're not going to stick an edit on a form and let someone just type any old thing and then assign that to a binding expression and execute it. That makes no sense. My suggestion of possibly obtaining a string from a service assumes that you are the publisher of that service and you are having some sort of authentication to validate that it is actually your application asking for the string and then providing that. It's my point was that this is something, being able to take a string and evaluating it at runtime, including the and include within that string the execution of methods, is something that was unavailable in any other form to Delphi developers. But it is possible now with the expression engine, and that's actually quite exciting. It allows you to do things that you simply could not do.
Okay, I'm just trying to get some of this stuff caught up too. Okay, let's see. I'm unable to get a live binding to change instantly when you type into an edit control. Again, not saying BCL or FireMonkey. That is on change instead of on exit. I tried setting the track property and tried calling binding list.notify. Neither helped.
Well, if you look back at the replay, when the replay is available, there was exactly that occurring between the two edits in my currency exchange example. There was a call to the bindings list .notify method on the on change of the of both of those edits, and so that now with visual live bindings, no, you're not going to get that to happen until you exit the control. But if you manually place a live binding, you can, and then this would be a managed live binding, and then you add a notify call on the on change, then you will get that synchronization on a character by character entry.
Yep. Yeah, I mean, you could also hook on key down, right? And every time a key comes in.
Yeah, sure, I suppose. And I'm not sure if I do on key down. It might be on key up or on key press or something. But you're right, exactly. Yeah. On change is a good one too, though. That kind of avoids all the kind of issues about the specific key press, unless you want that evaluation.
Yeah. Let's see. Gordon says terribly interesting equals bug ? I lost the context of
well, I think that goes back to the you with great power comes great responsibility. You don't want to expose this capability in a way that makes your applications wobbly.
Yep. Okay, patience is king. Let's see. Many thanks from Robert. CDS book is great too. Okay.
That's very nice.
Rick says, nice presentation. Let's see. Cary, yeah, okay, that's not well. Hi, Cary, are there any reserved words in expressions? I had a problem with live binding between a data set and a T-grid in FireMonkey where the column was called media type. It crashed the application when I changed the column type to M type. It worked fine.
No, there are not any reserved words. What you do have are you do have custom methods that are available. Now, I'm unaware of any kind of name collision with a method of that name. If you want to see the custom methods that are currently available to the expression engine from a live binding expression, then double-click the bindings list and then expand the methods property, and you will see all the currently registered custom methods for that bindings list. If you find that one of those methods actually conflict with a field in a table and you must reference that or a property of an object, uncheck that method in that property dialog box, and then that method will be removed from that context for that bindings list, and then you can use that conflicting name.
Yeah, and check the method. Okay. Again, all these things with plugins, if you register methods inside you're inside the ID, you're inside of the system. Same with components and property editors, component editors. We don't, there's no sandbox and things of that kind of those worlds. We give them full access through the APIs, of course, of the open tools. And then, of course, there's memory, and you can do all sorts of things in the world of memory. Is there a description somewhere how manual live bindings and visual live bindings interrelate? Walter was asking that.
Well, not that I'm aware of, but the one of the interesting aspects of visual live bindings is that they are not editable. So basically, if you need to do something beyond a visual live binding, you need to add additional expressions or manually create the expressions a la the XE2 style.
Yeah, and I'm just saying, if you go to the DocWiki page, there's a top-level live bindings overview page that then points you to the new things in XE3, the quick binding components, classes, and so on, and also to the existing binding mechanisms that are available. But maybe we need to ask the doc team to have an article that talks about how these things can interoperate. Obviously, there's still a binding expression, right? You can still even if you're using visual live bindings, the quick bindings, all of these things. If you double click on that bind expression, a non-visual component, it'll bring up that bind expression editor that was there in XE2, and you can look at the binding as you showed them, the formatters, the clear, all of those things are still in the live binding engine. There's just some new classes and capabilities in XE3. So, Cary, as a client dataset guru, I know you have a client dataset. You have a client dataset talk at 12. So if you want to defer this one, that's fine. Do you think that we can gain more time? Let's see. We gain many time by binding a T object to a T edit compared with T data source manner.
If I think I read that question as saying, will a live binding be more performant than the traditional data aware control to a data source? And the answer is no. A live binding requires a runtime execution or evaluation of an expression, and that takes time. Unlike the linkage that you get, the very tight linkage you get, and compile time linkage that you get between data aware controls and data sources, if I understand that question correctly. So I like to say live bindings are exceptionally valuable when the traditional mechanisms aren't available. And one of those places in FireMonkey for binding data to controls, or to bind data in VCL applications to controls that are not those traditional data aware controls. But if you have a choice between a live binding and an event handler, I would choose the event handler. If you have a choice between a live binding and a component-to-component association through properties that are built into those components, use those properties. Reserve the live bindings for the things that you can otherwise not do that way, because they do require runtime evaluation.
Yeah, again, depending on what your application is doing, this is like, gee, how fast is something if you allocate character at a time a billion times versus allocating a big bunch of memory and going through
That's right. Yeah, it's all relative.
It's all relative, and I haven't found, if somebody had 10 million expressions, I haven't found any speed issue, especially if you're dealing with user interface controls and user interaction. I would say the computer's waiting for your fingertips, in your brain. It's not. It's not sitting there like running a whole bunch of stuff in a separate thread and holding you up from doing something. So, and you have choices. So have at it. If somebody wants to run some benchmarks of bind expressions on user interface controls versus direct access to properties or direct access to controls, fields, and data sets, that'd be fun. It's your choice. It's your choice. Okay. let's see, using a TFMT BCD field and currency equals true under VCL when used TDB edit and is not focused. See the dollar and the comma. When it's focused, comma disappear. Using XE2T edit, I see dollar and comma when it's focused or not. Oh boy, this is long. Is there a way to change?
Yeah, this is a complex question. Yeah, is there a way to change this behavior, the way it works in VCL? I got it. I got the answer for that.
Okay.
I don't know.
Okay.
I don't know. I have never run into this issue. I don't know the answer to that. This might be something, if you play with it and you can discover the parameters of where things seem to be going wrong, you might want to put something on Stack Overflow or post it to an appropriate news group. Yeah.
Post it. Send me.
You may have identified something that needs to be addressed.
Yeah, I'm gonna explore that one too. Let's see. Let's see. What makes me nervous with LiveBindings is that refactoring can't see identifiers with its strings. Like if I rename a class or instance, it seems LiveBindings would break. Is this just a disadvantage you have to deal with if you want the advantages of LiveBindings? Well, there are many other dependencies, just because you're picking on LiveBindings. But go ahead, Cary. Maybe you want to offer some advice to Roger.
The answer is yes. This is a disadvantage if you want to deal that you have to deal with if you want the advantages of LiveBindings. They're strings. Even something like the syncing of text or doing the refactorings where it recognizes objects in scope, it's not going to go into your comment lines and change things either. So yes, it's just LiveBinding expressions are strings. They're not recognized as objects in the same way that references within your code are. So it is. I'm hoping that as LiveBindings evolve and mature, that there will be some tools, either third party or will be built into Delphi, that will give us additional capabilities here. But right now they're strings, and yes, that's whenever we're working with strings, there's we are limited to what we can, the support that the system could give us.
Now, I'm also adding my own personal note because I've talked about this with the Jim Turney, and I also did something in one of my 31 videos about how to defend yourself if things change, like, for example, the type of a column changes. There are so many dependencies in programming, not just with LiveBindings, but one of the things you could do is you could create methods. You could create a custom method that does things that you want in code that can be called from an expression in a LiveBinding that would defend yourself against changes, for example. And then if you refactor your project and your code, including these methods, and everything stays in sync. And of course, then you can have unit tests for your custom methods that are part of LiveBinding expressions to make sure you don't break anything.
Right.
And don't get me started.
David,
don't get me started on dependencies. Field types, column types. Unless you write code to test the types of things. If you've got a client data set or you've got code that assumes a Boolean type, and obviously there's converters in LiveBindings, but you write some code that's assuming Boolean type and somebody changes that to something else, you're going to get runtime exceptions and type mismatch.
Yeah.
There's all sorts of things that happen. Fields. Look at fields. Will Cary, you're the expert in client data set and fields. Fields have types, right?
Yeah, that's right. Yeah.
Unless you do something.
Say, David, there's one.
Yeah, go ahead.
There's one question I've been getting a lot in the last 24 hours, and since the fantastic news has been released that Marco Cantu is the new Delphi product manager, I've received lots and lots of questions about the future of Delphi development. Would you mind if I have a small announcement here? Sure. I am extremely pleased to announce that Delphi Developer Days is going to continue, and I am being joined by Bob Swart in presenting the Delphi Developer Days 2013. I'm going to be tweeting about that in the next 10 minutes, and I've already blogged about it at my blog. I'm very, very happy to join with Bob in bringing this important event to the Delphi community.
Absolutely. Very cool. Very cool. People out there, if you want 2 days of intense training on really serious development topics with Delphi, pay the money, fly wherever the closest location to you, go to Delphi Developer Days. 2 days, I don't know how many pages, you get 600, 2,000 pages of stuff. Total access to some of the top experts on the planet, and oftentimes surprise guests that are nearby or maybe are coming from sort of nearby. Unbelievable.
That's right.
Of brain bleed technical sessions that you'll walk away with massive stuff you can use immediately. I'm sorry, is that a plug?
Thank you very much. I appreciate that.